right, let's look over your normal model percentiles and percentages. So here at first, we just have z-scores given to us. So we already had those z-score values. And so here was asking for less than that z-score. So we went from negative infinity up to that value. Here we wanted greater than that z-score. So we went from that z-score up to positive infinity. Here we asked for between 1.2 and 2.55 standard deviations above the mean. So that's telling me these are positive z-scores, okay? And that matters. And now let's take a look at this next one. It asks for below. So what that's saying is that these are negative z-scores, all right? So negative 0.6 to negative 0.2, that was 14.65%. Now, you may say to yourself, well, I didn't include the negatives and it still came out right. Like you may have gone from 0.2 to 0.6 on the positive side. So because of the symmetry of the normal model, the percentages would come out the same. But this is going to matter. Paying attention to a detail such as this will especially matter if it had mixed it up. And I wish that I would have maybe made this number 5, mix it up. So it said 2 standard deviations below the mean to 1.5 standard deviations above the mean. So maybe it would have gone from a negative to a positive. Then it would have mattered that you were paying attention to that detail. In fact, I think I'm going to change that for next year's work. Okay, next, with number 6, we had to solve for the z-score. Remember to make sure you are saying z equals, because if you do not say z equals, you will not get credit on AP. And that was 1, so the area above. So you could have also just said, I know above 1 is 16% and rounded it to 16%. Okay, here we had how far away was 250. We wanted to see where weighed and they were underweight, so the area below. Okay, so we were going from negative 99 up to negative 2, so about 2.28, or if you had just used your normal model one saying the area below 2, you could have also said 2.5%. All right, here we have these IQ scores with a mean of 110, standard deviation of 25. So we had negative 0.4, okay? So that became the area below. Who scored less than that? 34.46. Here we wanted between two z-score, or between two context values. So you then found the z-score for the lower value and the z-score for the upper value. And then you norm CDF'd to get the area in between those two z-scores. All right, next we had 230 tests. How many of those students scored above a 96? So this is a two-step problem where you first had to find the percentage. So I got my z-score for 96 of 2.5. Then I said, 2.5 to 99. That's the proportion of students that scored above a 96. So only 0.62% of my students scored above a 96. Well, it wants to know how many students is that, not just what percent. So I have to take that value, multiply it by 230, and see that it says about 1 student then scored above a 96. So I rounded to the number of that would represent. Okay, so that was a two-stepper. So then that's what's happening on these other ones. You first are finding the percent of the area of the scores below 66, and then say, okay, 10.56% of the students scored below a 66. Well, that percent of the 230 students equals about 24 students. Okay, two-steppers. So this is within 1 standard deviation. So that's 68% of the 230 students. All right, next, this is similar to the one up above, because once you find those percentages, you are then going to compute the number of nails out of a bag of 120. So find the percent. For this case, it was below, or less than 4.94 inches long. So that was 11.51%. Then I multiplied it by 120 to see that that's about 14 nails. Okay. Next, this was between two amounts. So I turned those two X values into Z scores, got that area in between, and then I had to turn that. So about 4.78% of nails are in between 4.97 and 5.03 inches long. So now I need to multiply that by 120 in the bag to say that about 6 of those nails in that bag are in that range of lengths. Here was the over 5.03. So that's 47.61%. So that out of 120 nails was about 57 nails. All right, next. So here it was one similar to day one's assignment, about 95%. You had to know this was within 2 standard deviations, so it was symmetrical. So you had to then do, that was the mean on either side of that, and then they were 2 standard deviations to find that. So 3.75 here. So let's see. So it tells me the standard deviation. So you could do this a couple different ways. So we know she got an 84. So that was the result. So you can see right here on the left, the mean plus 1 standard deviation. She scored 1 standard deviation above the mean. So the mean plus 1 standard deviation is Phyllis's score of an 84. Okay, well, they tell me that 1 standard deviation is 6. So then that tells me the mean was a 78. Okay, if I can do that correctly. But here's another way, and this is going to kind of lead us into some of what we're going to do on the assignment today, or the notes today. So here, a z-score is 1, because a z-score is the number of standard deviations. Then we've got 84 minus the unknown mean divided by the standard deviation of 6. So then you just have all the values except for that 1, and so you then solve for that missing value. Okay, we're going to kind of bridge to this idea over here on the right-hand side when we do today's lesson. So, but you can also think of it like this on the left-hand side. Okie dokie. Next, these are within 2 standard deviations, so then you've got that there. Here we have fall above a 70, so I find a z-score of 2.86. So only this percent, only 0.21%, so a fifth of 1%, so a little bitty, are above a 70. And then here was between 2 values. So we had to find the z-score for both of those values, and then we got our area, the 78.54%. Here, so this one said, approximately 99.7% of all cases will lie between which measures? Well, so I know that 99.7 is a magical number of 3 standard deviations above the mean and 3 standard deviations below the mean. So I came over here and I said, okay, the mean plus 3 standard deviations is 64. The mean minus 3 standard deviations is 40. And so therefore I know that 99.7% of data is between 40 and 64. Number 17, finding that z-score for a 600 lifetime long battery, and then going above that. So only 5.05% of all batteries are going to last that long, okay? And now look, here's another one that was a two-stepper, because not only did we have to find the percent of students that go above a score of an 80. So I did 80 as a z-score. And then I calculated the area above. So that's 12.71% of students scored above an 80. Well, out of the 120 students, that's 15.25. Therefore, about 15 students scored higher than an 80. So again, a two-stepper, taking it from your percent to the number of items out of a total. All right, so that was your percent and percentiles, but then also making sure you could do that, how many out of a total extra step. Okay, hope that helped you.